Hi girls, this lesson is going to teach you how to find the quadratic equation of a function from its graph. Okay, so let's look at question A. This one has x-intercepts at x equals -1 and x equals 3. To get those x-intercepts, then I need a function that starts with y equals, and I need factors of x plus 1 to get -1, x equals -1, and x minus 3 to get x equals positive 3, sorry. The only thing we don't know is what the coefficient of x squared is. So in other words, there could be a number out here called a that we can multiply everything by. We just don't know what a is. To find a, we substitute another point that we haven't used yet that we know lies on the graph. The only other point at the moment we have is this point here, the y-intercept of 3. So that point there has coordinates 0 for x and 3 for y. So we're going to sub that point in to work out what a is into our equation. So y is 3, so 3 will go where y was. A is still a because I don't know what it is. And then in the brackets, I've got 0 plus 1 because x is 0 times 0 minus 3. So I get 3 equals, now let's think about the brackets. This bracket just becomes 1. This is -3. So 1 times -3 is -3. And that's timesing a, so I just get -3a. To get a by itself, I divide both sides by -3. And finally, I get -1. So therefore, y equals -1 outside of x plus 1 times x minus 3. And hopefully you realize I didn't really need that -1. I could have just put it as a negative like that. Now girls, you don't have to do any more than that, you're actually finished. But can I just show you that if I expand that, I'm just going to expand the brackets first. Don't try and do too much at once, you get confused. So if I expand the brackets, x squared minus 3x plus x, that becomes minus 2x. And then minus 3 there to there. And then I times all this by the negative out here, and I get -x squared plus 2x, plus 3. Now, I just wanted to show you that when we expand it, if we get this quadratic, it makes sense that it goes with the graph because of the negative in front of the x squared. That means it's concave down, just like our graph in A is concave down. So it all makes sense. Okay, now for B. We've got only one x-intercept. So what that tells me is, you can think of it in two ways. If x equals 2, that means a factor has to be x minus 2. Now, you could think of this as one root or two double roots, like two equal roots. So which will give you two equal factors, which you could write like that. Or you could realize, wait a minute, that's just x minus 2 all squared. Okay? But what have I forgotten? I've forgotten the a on the outside, so I don't know what a is yet, so I better put an a there. So what other point do I have to work out what a is? I have this point here, and that has coordinates 0, 8. So I'm now going to sub in that. So I put 8 where y was, equals a times 0 minus 2 all squared. -2 squared, all squared, is 4, so I get 4a equals 8. Divide both sides by 4, and I get a equals 2. Now, remember, you've got to answer the question, and the question wanted our actual function, the equation, so you can't just stop there. So my final equation is y equals 2 outside of x minus 2 all squared. Now, please keep in mind, it's just a coincidence that this is 2 and this number in here is 2. That won't always happen. Okay, so for the next example, it says find the equation of the quadratic function with this graph now. Okay, so girls, what do we know? This is interesting. We've got the axis of symmetry down the middle at x equals 1. But we only have one of the x-intercepts. What are you going to do about that? Hopefully you know that this distance here from the axis of symmetry to the x-intercept should equal the other distance between the axis of symmetry and the other x-intercept. They're equal distances. Now what is that distance? Well, from 1 to get to the y-intercept, which is 0, so that's one length, and then we've got 2 more lengths to get to -2. So altogether, that distance is 3. Therefore, this distance has to be 3 as well. So if that point there is 1, then if you add 3, that there must be 4. So their x-intercepts are -2 and 4. I'm just going to write that down just to make it clear. So my x-intercepts are -2 and 4. So what does that tell us about our function? Y equals, well, for x to be -2, one of my factors must be x plus 2. Remember, we're swapping the sign. And for x to equal +4, one of my factors must be x minus 4. But what have I forgotten? I still don't know what the coefficient of x squared is, which is a. So I need to put that in there as well. You might be wondering, well, why don't I add a c over here? Why don't I add a constant term? Well, then these two factors wouldn't be factors of the entire expression if there was something else over here. And therefore, if that was the case, I wouldn't be getting these as my x-intercepts. So that's why there's definitely no constant term over here that I need to worry about. Now, what other point do we have to sub in to find A? We have this point here. It's again a y-intercept. Just so you know, girls, if you had another point that wasn't a y-intercept, for instance, the point here, let's just make it up. I'm making it up. It's like, let's say it was 2, 5. You could sub that in as well, where x is 2, y is 5, and then solve that to work out what A is. So as long as you just have one other point, whether it's a y-intercept or not, and you sub that in. But this isn't part of the question, so we're going to ignore that now. So, girls, we're going to sub the point, the only other point we have, which is 0, 16. So let's sub that in. 16 is y equals A, I don't know, times 0. Now, 0 plus 2, that's just 2, times 0 minus 4, which is just -4. I'm going to do it that way this time. Then all of this becomes -8a equals 16. Divide both sides by -8, and I get A is -2. So therefore, my equation is y equals -2 outside of x plus 2 times x minus 4. All right, let's keep going. Find the equation of the quadratic graph whose graph cuts the x-axis at 4 and -3, and which passes through the point 2, -20. And give your answer in the form y equals x squared plus bx plus c. Okay, it looks hard, but it's actually the exact same question that we've been getting already. Now, you don't have to do a sketch, but let's just do a quick sketch just to make sure we understand what's going on here. So if I have xy axis, my x-intercepts are at 4 and that was a bit close, -3, and passes through the point 2, -20. Where would that be? Well, 2's like here. -20 would be down here somewhere. So if I need to pass through a point all the way down there, my parabola must be concave up. Something like that. I'm not sure exactly what it looks like, but it has to be concave up for it to hit that point. So that gives me a clue that A is going to be positive. We'll see what happens. So now, what do I know? I know my x-intercepts are -3 and 4. So that means in my function of y equals, my factors are going to be x plus 3 from x equals -3 and x minus 4 from x equals 4. But I don't know my coefficient of x squared, so I better put an A out there. Okay, so what else do I know? I know that it sits through the point 2, -20. So let's sub that in. Sub 2, -20. So I get negative 20 equals a times 2 plus 3, 2 minus 4, which equals a times 5 times negative 2. 2 minus 4 is negative 2. So I get negative 10a equals negative 20. If I divide both sides by negative 10, I get a is 2. So we have the function y equals 2 times x plus 3 times x minus 4. Now, but wait a minute, they said to give your answer in this form. So this time, I have to expand it. And it's important that you do, otherwise you might lose marks. So now to expand this, what I would do is I'd leave the 2 out the front and expand my brackets to get x squared minus 4x plus 3x, which is minus x, minus 12. And then times all that by 2, and I get that. So that's my final function in the way they wanted it to be. Okay, here's a couple more. Find the equation of each quadratic given its graph. Oh, this is interesting. Look at A. We don't know the x-intercepts, but what do we know? We know the vertex. So, if the vertex is that, we know the function is of this form. Y equals a outside of x minus h squared plus k, where the vertex is hk. Now, girls, notice this h and that h, it changes sign. You've got a positive h here and then a negative h there. But this k and that k, they're both seemingly positive, so they stay the same sign. So that's an important point. So if the vertex is actually 3, negative 2, therefore h is 3, but k is negative 2. So you've got, there's our value. So let's sub them into our function. So our function is y equals a times x minus h, so it becomes x minus 3 squared, plus k, which is negative 2. So we're adding negative 2, and we could just write minus 2 instead. So that's fine too. But wait a minute, once again, I still don't know a. So what other point do I know? I know the y-intercept, which is 16. So I'm going to sub in the point 0, 16. So I get 16 equals a, I still don't know, times 0 minus 3 all squared minus 2. Now I might add 2 to both sides to cancel that 2 out. So I get 18 equals, now here I get 0 minus 3 is negative 3, negative 3 squared is 9, so I get 9a. So a must be 2, because I divide both sides by 9. So now that I have that, therefore y equals 2 times x minus 3 squared minus 2. And since they didn't give me instructions to write it in any particular way, I can actually leave it like that. Okay, so for the next one, okay, I'm just going to put a box. So for B now, it's a similar sort of thing. Once again, I know the vertex of the graph, negative 4, 2. Therefore, I need this form again. Y equals a times x minus h squared plus k, where the vertex is hk, which means if the vertex is negative 4, 2, and that's h and that's k, then I get y equals a times x minus h, which is negative 4, plus k, which is 2, so plus 2. So let's rewrite that. Y equals a times x plus 4 squared plus 2. Now, what other point do I know? This time, the only other point I know is an x-intercept. So I can work out that that point there is negative 2, 0. It's the other way around. So I sub negative 2, 0. And I get, okay, so this time 0 is y equals a times negative 2 plus 4 squared plus 2. Again, I might minus that constant 2 out on to the other side. I get, so because I want a by itself. It's like an equation now. And so I get a times negative 2 plus 4 is 2. 2 squared is 4, so I get 4a. Then if I divide both sides by 4, I get a equals negative a half. So therefore, y equals negative a half times x plus 4 all squared plus 2. That's from this equation here. Okay, now let's just look back at the graph. Does it make sense that a is negative? Yes, because it's concave down. Also, girls, there's another way you could have done that. I'll just quickly explain. Girls, here's the axis of symmetry because it always goes through the vertex, right? What's the distance from here to here? If this is at x value of negative 4, that distance there is 2, which means that distance here is also 2. So what's that x-intercept? Negative 6. So by using the two x-intercepts, you could also do it the old way where you have y equals a times. You'd have from the x-intercept of negative 2, you'd have x plus 2, times from the x-intercept of negative 6, you'd have x plus 6, and then you'd sub in the other point that you have, which is the vertex, to find a, and go from there. So sometimes there's more than one way to do things, and that's okay. You can do it whichever way feels more comfortable to you. So now this content corresponds to exercise 1D in your textbook, so you can give that a try. Thank you.